Hi, this is another video for my GCSE electronics students. This time we're going to have a look at question 3 from the mock exam, and these were the class averages. You can see that question 3 was significantly less than the first two questions, so class average is 61%, so there's going to be quite a few of you who would benefit from watching this video. Right, first thing then, diagram shows a logic system. Okay, we've got inputs A, B and C and the output Q. Hopefully you can recognize this is a NOT gate, an AND gate and an OR gate. Now we have to write down in terms of A, B and C these expressions. Now this is something that even A-level students often get wrong. If you write anything here other than A, B's and C's, like if you write X or Y or anything else, then you're going to have the wrong answer. Okay, you've got to be really careful that your answers are only in terms of A, B and C. I should give you an example of how to do that now. Okay, so X, what is X? Well, X is, we've got A and then we've got not A. So in other words, we've got a bar there. Okay, so this answer is a bar, or read that one as not X. Oh, sorry, not A. Okay. Okay, so then we've got output Y. Well, output Y, remember this is an AND gate, so we're going to AND B and not A. So in other words, B and not A, so B dot A bar. And so in other words, for this one, make sure you don't do like B dot X, because that wouldn't be in terms of A, B and C. So B dot A bar. And just for consistency, I'm going to try and do them in reverse alphabetical order. It's quite nice that if you just stick with one system rather than sometimes flipping them around. Okay, not really going to make any difference to the mark here. Well, it won't make any difference to the mark, but it's going to make your life easier when you do more complex things. You're trying to compare your answers with another student. So, right, the next one then, we've got an OR gate, and that's going to OR C, or, okay, remember the plus means or, so C or, and then on the other side of the input we've got B and not A. Now some of you might be thinking, oh, maybe I should put brackets around these, which you could do. It's not going to hurt, but with the precedence of operators, like in BidMaths, with maths, you know, some things happen before others. Not happens first, then the AND, and then the OR. So basically, this stuff happens before you then do the OR with the C. Okay, so it doesn't matter. Once again, you've got to write down this answer in terms of A, B, and C, making sure that you don't write anything like Y. So we've got C, OR, and then B and not A. If you put brackets in, you wouldn't be marked down. It's just unnecessary. Okay. Right, next bit then, we've got to complete the truth table. So do each column in turn. That's probably the easiest way to do it. And we've got X, and X, if you remember, X is just not A. So we're just going to take all of these and we're just going to flip them. Okay, so 0 becomes a 1, 1 becomes a 0. Okay, that's the first bit. And it's a 3 marker, so you get 1 mark for each one of these columns if you get them correctly. Y is going to be B and not A. So B and we've already done the not A, so you can do a B and X, if that makes sense. Okay, so 0 and 1 is going to be 0. 0 and 0 is going to be 0. 1 and 1 is 1. Okay. Like so. Then we've got Q. Now Q is going to be C or B and not A. So if C is true, we know, because it's an OR, we know that the output's going to be true. So in fact, I'm just going to do that because that's really easy to start off with. C was true, so the output Q will be true. And now what we need to do is OR B and not A. Well, B and not A, that's Y. So let's just check whether it's Y. So we can do this. All right, so hopefully that makes some sense there. If you want to look at it another way, how else might we look at it? So we could do it like this. So we C or, so C is 0, so we can ignore that one for a moment, or B and not A. Remember, B and not A is the Y. So 0 or 0 is 0. 0 or 0 is 0. 0 or 1 is 1. 0 or 0 is 0. 1 or 0 is 1. And in fact, as soon as you got the 1, you don't need to look at it, but I'm just going to do it longhand anyway. 1 or 0 is 1. 1 or 1 is 1. 1 or 0 is 1. Okay. Hopefully that's covered that one for you. There were a number of people who got that wrong. There were a lot of people who got this next part wrong. So we should be able to redraw a logic circuit using only NAND gates. And so we need to redraw this. And it's got the inputs A, B, and C. And it's got the output Q, like so. And now we need to replace these gates with NAND gate equivalents. Okay. First one is a NOT gate, so we need NOT A, and that's easy to do. I think most people are familiar with that. You tie both of the inputs together and then you NAND them. And so I'm just going to annotate this as we go along. Okay. Next bit is an AND gate, and we only have NAND gates available to us. So what I'm going to do, I'm going to use a NAND, and then I'm going to NOT the NAND. Hopefully, once again, most of my students are going to be familiar with that. So by that point, we've NANDed the A and the not, sorry, the B and the not A. So B and not A, we NAND that, okay. But we want to get rid of, because we want to do an AND, not a NAND, we want to get rid of this bar. So we're going to NOT that again, because two knots that cancel out. Okay, so that now gives us B and not A at that point. So this, or these are equivalent to a NOT, sorry, an AND, an AND. All right, they're equivalent to an AND, whereas this is equivalent to a NOT. And then the next bit, then we need to have this OR. Now, an OR is going to need 3 logic gates. Okay, it's going to be 2 NOTs, like that. Run out of space here, and then go into a NAND gate, like so. Okay, that is an OR gate. Now, some of you may be a little bit stuck as to why that is, although we have covered this before, but fair enough, you know, people forget. So let's have a simple example. So A or B. So we've got A or B, which, you know, A, B, that, and we want to do that as an AND gate equivalent. And what I said to you a moment ago was that we can do it like this with 3 logic gates. Use a NAND gate, just tie the 2 inputs together, so that makes it a NOT gate. So that's NOT A, and that's NOT B, and then let's bring those 2 together and take that through another NAND gate. So that's now going to be NOT A, NOT B, and then NANDed, because remember that's a NAND gate. Now, if you remember De Morgan's law, we can split the bar, change the sign, which then gives us not A or not B, and the double negatives, they cancel out, which gives us A or B. Okay, so that is equivalent. These 3 are equivalent to that. It then says cross out any redundant gates. So you're looking for 2 sequential NOT gates. Got to be careful, like this is not configured as a NOT gate, that is just a NAND gate. So you couldn't cancel that and that together. You're looking for 2 sequential NOTs. 1, 2, these are NOTs, they're the only ones to cancel out. okay, and do cancel them out with single strikes like that. If there was another pair, I would do like double strike to make sure that they were that it was clear how I was pairing them up. Okay, that's the end of that question. I will record another video for the next one.